On the previous page, there was a quiz that talked about a hypothesis test. So this page kind of talks about in detail the solutions to that. If you didn't receive a score of 100%, review these answers as another worked example. The scenario was Americans averaged 6.9 hours of sleep on weeknights, according to a report released in 2011 by the National Sleep Foundation. A student in a statistics class at Los Medanos College wondered if the average amount of sleep on weeknights is different for students at that college. She collected data from a survey of 43 randomly selected students at LMC, the college. Respondents averaged 7.12 hours of sleep a night with a standard deviation of 1.45 hours. Now let's check the conditions. Okay, first we consider whether this is a random sample from a population of interest. Since we are told that this is a random sample of students at this college, we conclude that we have a random sample from the population of interest, which is all students at this college. Next, we consider whether the conditions for all the use for the use of a t-model are met. First of all, the sample size is 43. This is large enough to proceed with the t-test, regardless of the shape of the distribution. It could be skewed right, skewed left, could have outliers. It doesn't matter. Our sample size is bigger than 30, so we can definitely use the t-test. Okay, now we'll calculate the test statistic. Okay, let's see. Oops. Let's zoom in a little bit because it's hard to see. The standard error, I think, we don't really care too much about the standard error, but it's part of our calculation of the t-value. So we might as it's the denominator. We might as well figure that out first. This estimated standard error is S, which is the sample standard deviation divided by the square root of n. The sample standard deviation was given. It was 1.45 divided by, okay, the square root of n. N is the sample size. They said 43 students. So if you take 1.45 divided by the square root of 43 on your calculator or on your phone, whatever, you get 0.22. So that'll be the denominator when we calculate the t statistic. Okay, so its numerator is the statistic minus the parameter. So we got, as we calculated things, we got 7.12. Oh, dang it. And then 6.9 was the parameter. I think that was the given assumed mu. And if you calculate that 7.12 minus 6.9, you divide that point by 0.22, you get about 1. It's pretty close to it. So the test statistic t is 1. Okay, now that we know that, we can kind of zoom out and kind of think about that. Now that we know the test statistic t, let's think about the p-value. We can figure that out by using the applet or our calculator or something. Set the degrees of freedom to, remember, degrees of freedom is n minus 1, so 43 minus 1, 42. So we set on our applet the degrees of freedom to 42. And then since the alternative hypothesis is that mu is not equal to 6.9, that means we want the area in both tails, which is instead of calculating the area in this tail and the area in this tail, we'll just find the area in one tail and double it. So it says, yeah, double the area in the right tail, or it doesn't matter, the left tail, whatever you want to do, but just the right tail, just for whatever. The area in the right tail is 0.1615. If I double that, multiply by 2, I get 0.323. This is the p-value. So here's a picture of the applet showing the results. Okay, p-value. I took this and I doubled it. Multiplied by 2. Okay. The conclusion is, since the p-value is about 0.323, that's larger than the significance level they gave us. Alpha was 5%. If you move the decimal to the right, or sorry, to the left twice, you get 0.05. That's bigger than 0.05. Then we fail to reject the alternative hypothesis. Conclusion and context. Okay, the data from this study does not suggest that the amount of sleep for students at this college differs from the national average of 6.9 hours. The p-value is about, and you'd state the p-value just for those that are reading your article that understand statistics. This sample of students from this college sleep on average 7.12 hours, but the difference is not statistically significant and could be explained by predictable variation that occurs in random sampling.